This lesson is a continuation of section 3.6, solving proportion using cross products. The last lesson I showed us how we can solve certain problems using the cross products method. This lesson is mainly going to focus on how we can set up some word problems with a proportion and use that to solve and find the right answer. If you're following along taking notes, the first thing I want you to do is make sure you get this paragraph right here. When I talk about solving word problems using a proportion, if you can, first of all, find or figure out the fact that this word problem that we're talking about sets up with a proportion, that's a great first step. But then from there, you need to also set up the proportion correctly. So the main thing I'm going to talk about is make sure we stay consistent with how we arrange the information in the proportion. If you don't arrange the information correctly, you still won't get the correct answer. So for example, as I have there in red, if you put dollars on the top of one of your ratios, make sure you also do that with the other ratio. Remember, when you're setting up a proportion, it covers two different ratios. So let's say here's a ratio A over B, and then we have another ratio C over D. The equal sign between them tells us this is a proportion problem. If in one of these proportions I put dollars at the top, let's say letter A stands for some amount of dollars, then C also needs to be for an amount of dollars. And same thing also with B and D. Let's say that's an amount of pounds. Well, in this case, let's say if B is an amount of pounds, then D also needs to be an amount of pounds. So I need to stay consistent with what I have on the top and what I have on the bottom. It wouldn't matter if I flip-flop these two. Let's say I put the pounds on the top and the dollars on the bottom. It wouldn't matter, but I just have to make sure I do that for both of them. So let's say A and C, like A and C always have to stay across from each other, and B and D would always need to be across from each other. I could put them either way, with either one on top and bottom, but I need to stay consistent with how they're lined up across from each other. And also one other thing I'll talk about a little bit more too is each ratio also needs to make sure that you stay consistent within that too. All the information in ratio 1 should be consistent. All the information in ratio 2 should be consistent. Let's say this is talking about like store number 1, like what they charge per pound for oranges or some kind of food. Then store 2, then all their information needs to be in the second ratio. So again, on the tops of the ratio, or on the top of the proportion, on the bottom of the proportion, and even within each ratio, you need to stay consistent with how your information is arranged. And I'm going to go through a few examples here to kind of show what I mean by that. So the next couple problems, I'll talk about how that should look in your word problems when you set them up. So my first example here, I'll read the problem out loud, and we have a nice little picture with it too, but this is a very common problem you may see even in trigonometry as you go on, or even just there are problems that deal with similar triangles, but even we can solve this just using a proportion too. So a problem kind of like this. The problem says a boy stands in the shadow of a shady tree. He lines up his shadow with the tree's shadow so that the very tops of them are at the same point. His shadow is 10 feet long while the tree's shadow is 32 feet long. If the boy is 4.5 feet tall, then how tall is the tree? So again, what we're going to try to find out here is how tall the tree is. If I draw a line from the bottom of the tree to the top of the tree, this is the distance right here that I'm trying to find out. So we're going to call that x. That's our unknown. That's our variable. And then the height of the boy. One other thing that I do know, the height of the boy also, as he stands here, is 4.5 feet. So I know that. But notice what I've done now by drawing those heights in. I've made two triangles here. Here's the triangle for the boy, and here's the triangle for the tree. Each one has the shadow's length, and it also has their height. But the tree is the one that I'm trying to find. So again, a very, very common problem here using similar triangles. So I'm going to make some kind of proportion to set this up. So one ratio equals some other ratio. And again, I'm going to try to stay consistent within each one. I'll show you how I'm going to do that. In this particular example, what I'm going to do is I'm going to put all the boys' information in my first ratio and all the trees' information in my second ratio. This is one way I'll show myself being consistent here. I'm going to try to spell tree correctly here. I think I can. T-R-E. There we go. At least show it that you can see it. So the boys' information in the first ratio, the trees' information in the second ratio. Also within each ratio, again, like I showed above, I got to make sure I put the same types of numbers at the top and the same types of numbers at the bottom. Well, what do I know? Let's talk about this first ratio. What do I know about the boy? I know that his height is 4.5 feet. And I know his shadow's length is 10 feet. So again, when I arrange the information, let's say I put 4.5 on the top, that's his height, and 10 feet on the bottom, that's the length of his shadow. So what I've done is I put the height of objects on the top of my ratio, and I've put the shadow's length on the bottom of my ratio. So since I've chosen to do it that way for the boy, I have to make sure I do the same thing for the tree. So here's the height of the boy. On this side, I have to have the height of the tree. Again, that has to stay consistent. In this problem, the height of the tree, that's what I don't know. That's my x. So I'm going to put x there. In terms of the shadow of the boy is 10 feet. I have to make sure I put the shadow of the tree on the bottom over on this ratio. That I do know is 32 feet. Since I've stayed consistent, this should be a good setup for this problem. Again, notice, even in the first ratio, this is all information about the boy. The second ratio is all information about the tree. And then even on my tops and my bottoms, I made sure that I put the same types of numbers. This is what I'm talking about when I'm saying trying to tell you be consistent when you're setting up your proportion problems. Now if I cross multiply like we learned in the last lesson, this should be able to set up an equation for me that I can solve and get the correct answer. 10 times x gives me 10x. And 32 times 4.5 I think gives me 144. I'll double check that in here in a second, but I think that gives me 144. And then if I'm solving this equation, I just divide both sides by 10, and x is going to equal 14.4. In this case, again, what did I find? 14.4 feet. I think that makes sense. Obviously, the tree should be definitely taller than the boy, so I should get an answer that is taller. That's kind of another way you can check your problems, too. I mean, think about, does your answer make any sense in this context? So, but good, 14.4 for the answer for this first problem. But again, the main thing I want you to realize in this problem is that we stayed consistent to set up our proportion. That's why it worked out. In our second example here, we're going to again try to set up the problem, set up some kind of proportion, and make sure we do the same thing as the first one. Stay consistent with how we arrange the information. It says you're making cookies for a bunch of your friends. The recipe calls for 2.5 cups of water for 6 batches. So we know that about the recipe. How much water will you need if you want to make 16 batches? In this particular problem, here's how I'm going to set up my two ratios. Again, it's going to set up with a proportion, as we can kind of figure out, and that's as we kind of know that because we're in the proportion unit. But if you read this problem and you see, oh, it sets up with a proportion, that's a good first step. Now we have to make sure we set it up correctly. We'll say that this ratio is going to be all the stuff we know that's in the recipe. So the recipe tells me this, and then this particular time where I'm cooking up cookies, or this particular batches that I'm trying to make, we'll say that this is what I'm making this time. So that's gonna be my second ratio. Again, the kind of like what I'm making this particular round of me cooking for my friends. So we know what the recipe calls for, and then what am I making in this particular case. So that's kind of how I'm going to describe these two ratios. Again, how I set up the two ratios is important. Also, what I put in terms of the tops and the bottom is important too. So important numbers, I know that I need 2.5 cups of water. So let's pay for the recipe. Let's put that on top. 2.5 cups of water. And that makes 6 batches of cookies. So I'll put 6 on the bottom here. So again, what I've decided to do is I've decided to put water on the top here of one ratio. And I've decided to put batches on the bottom. So when I arrange the ratio for what I'm currently making, I have to make sure I do that same thing on the other side here. Water on the top and batches on the bottom. As long as I do that, I should be okay. Well, in this particular problem, what I'm trying to figure out is how much water I need. So that's what I don't know. That's my variable, my unknown. So x, in terms of what I'm making, how much water do I need? I don't know. That's my variable. It will make, I know those 16 batches, so that's my other number. And again, notice how we stayed consistent through the whole proportion. Here's what the recipe says. Here's what I'm making. But again, even on the tops and bottoms, I made sure that I stayed consistent. I'm going to also just kind of rewrite this ratio, just so you can see that it wouldn't matter if we flip-flop the top and the bottom. I would still get the exact same answer. If I put water on the bottom, batches on the top, it actually does not matter. I'm going to just kind of write that over here. If I flip-flop the tops and bottoms, my new ratio would actually be 6 over 2.5 instead equals what? 16 over x. Okay, so just kind of keep this off to the side and keep this in mind that here's what I would have if I flipped that ratio around, or just had water on the bottom, batches on the top. Let's go back to our original one here though. What happens if I try to cross multiply and solve this? Well, I should get the right answer. 6 times x and 2.5 times 16. I'm going to multiply those things and make each side of my equation. 6 times x gives me 6x. 2.5 times 16 I think gives me 40. If I go back to the one where I've flip-flopped the numbers. Now check this out for 1 second, and you'll see why this is important to just make sure that you set things up consistently. But if you do that, it won't matter. If I cross multiply this one, notice what happens. I get 6 times x, which is also 6x, and 2.5 times 16, which is also 40. So here's what I'm saying again. As long as you stay consistent, it doesn't matter really what ones you put on the top, which ones you put on the bottom, and you'll even find out that you can even flip-flop the ratios. That's fine. But as long as you stay consistent with your categories, you and your neighbor could do the problem 2 different ways and still get the same answer, or these 2 different setups and still get the same answer for this problem. It can still work out for either of you, just as long as you stay consistent. Finishing up the problem here, 6x equals 40. If I divide both sides by 6, I get x equals 6 2/3, or x equals 6.6 repeating. I think kind of either of those answers would be acceptable, but 6 2/3 batches I think kind of makes sense. So there's a second example of just showing how if we stay consistent, we'll get the correct answer for our problem that sets up with a proportion. We'll set up one more problem just as an example of how to set up one of these word problems with a proportion. And again, just in terms of showing how we stay consistent, or how you should think about grouping the categories. It says each day the seals at an aquarium are fed 8 pounds of food for every 100 pounds of their body weight. One seal at the aquarium weighs 280 pounds. So how much food should this seal be fed per day? When you're setting up these problems, as you've noticed that I've done in the previous 2 here, I would suggest making little headings like this, like recipe, or like how much you're making, or water, or batches. That will help. You'll see me do it often on the board when I'm doing these kind of problems. Or same thing I did for the first one. I did height, shadow, the boy, the tree. I think that will help when you're setting up some kind of proportion, especially if you're having trouble. So definitely have those kind of words nearby to say, okay, well, what does this ratio stand for? Or what is on the top of each one of mine? So you don't have to, but I think that is a big benefit. In this particular case, I'm going to say that I'm going to put all seals for all the seals at the aquarium. Here's what they're fed. And then this one seal that they're talking about, he's fed, we're going to figure out how much should he be fed in terms of food. So, and that's what I'm going to have for my first ratio is all the seals, what they're fed. And then the second ratio is just what this one particular seal is fed, or that's what we're trying to find out. Again, the tops and the bottoms, I have to make sure I also stay consistent on that. For what they're all fed, again, I see 2 pieces of information. I see 8 pounds of food. They're fed for each 100 pounds of their body weight. And again, just to show you, or kind of prove to you that it doesn't matter actually which one I would put on top, I'm going to put the blue one on top this time. Usually I've put the green on top, blue on the bottom, but I'll show you it does not actually matter. So again, we'll put their weight. In this case, I'll put that on top, 100 pounds. On the bottom, I'll put they need 8 pounds of food. So how many pounds of food is going to be on the bottom? So, but in general, I still stayed consistent with all the seals. Here's what I know about them. For every 100 pounds of weight, they get 8 pounds of food. Again, now I just have to stay consistent with my other ratio. So when I'm looking at this, the weight of one seal, I do know that. The one seal we're talking about is 280 pounds. And what I'm trying to find out is how much food he gets. So there's where my X goes. Again, in all this second ratio is just the one seal. But in all this, I stayed consistent with my categories. All the information of weight is in blue. That's on the top of my ratios. All the information with food is on the bottom. And each particular ratio is either all the seals or just one of the seals. So as long as I stay consistent, this setup should work. And you'll even find, again, if you can even kind of play around with your own way to solve this, I guarantee you get the same answer as me as long as you stay consistent and have categories like this. If I cross multiply, try to solve this now, 100 times x gives me 100x. 8 times 280, I think gives me 2,240. And then if I just divide both sides by 100 to get x by itself, I'm going to get 22.8. Again, if I'm thinking about what that means in terms of this problem, it says how much food should this seal be fed per day. So he should get 22.8 pounds of food. And again, does that make sense with my other answer, or what I know about this problem? Well, yes, for every 100 pounds, he gets 8 pounds of food. So this one's almost 3 times as much. This one seal is 3 times as much as the unit rate. So yeah, that makes sense then that he should get about 3 times as much food. 3 times 8 is about 24, so he's almost up to 24 pounds for this guy. So that should make sense. But again, each one of these reward problems, the biggest thing I'd want you to understand out of them, or get out of today, is that we stayed consistent with how we set up each proportion problem. In the homework today, all the problems should be problems that will set up with a proportion, but as long as you stay consistent setting them up, you should be able to get to the correct answer.